In this video we're going to look at ways of improving the subgrade or the foundation. As mentioned before, some soils are not strong enough to support the loads that they are required to support. No matter what you do with the compaction, whether you've got the optimum moisture content or not, they need a little bit more work to enable them to carry the loads. Now that might be because the soil itself is too soft, or it may be that the load is too high in the case of, say, a building or something, or it may be a combination of both. Either way, the soil is not going to be strong enough to support the load. If the soil settles, and the result of that, it may be that the soil will settle over time, which means that the structure that it's supporting is going to settle over time as well. Even worse, it may settle in some spots and not settle in the others, in which case you get differential sediment, so the structure may tilt or have potholes or things like that. So it's undesirable. You need to bring the soil surface up to a state where it will support the structure, it won't settle, and it won't fail either. So where this is particularly pertinent are things like such as roads, especially in Auckland, where you've got a subgrade layer, the existing ground, and the material underneath the road is the clay material is called the subgrade. If it settles, then the whole road's going to settle because this is a flexible pavement. So you need to make sure that it's strong enough. Another thing could be a structure. If you've got shallow foundations, in particular pad foundation or raft foundation, and sometimes slopes need to be stabilised too because they're unstable. So there's different ways of doing it: dynamic compaction, vibro compaction. So these ones here are ways of increasing the amount of compaction. This one here, preloading and wick drains, enables you to hasten the consolidation. So the consolidation happens before you build the structure on top of it. And lime and cement stabilisation allow you to increase the strength of the soil. So dynamic compaction involves basically dropping a big weight onto the soil. Obviously compactors, rollers can only be a certain size. With a crane mounted weight you can have a much heavier weight and you can drop it down, so you can put more compactive effort into the material. So it collapses the soil voids to form soil particles into a more dense form, and increases density and therefore increases the shear strength. Variation on that is vibro compaction, where you put a vibrating machine in there and you vibrate the soils. In particular, this works especially well for sands and gravels. Not going to work so well for clays. All you're going to do is turn it into mush. Once again, it vibrates the soil particles into a more dense form. So there they are there, they vibrated and they form a tighter matrix, if you like, and therefore they're denser, therefore they're stronger. The reason why they're stronger is shown here. So you can see there's 4 points of contact on the soil particle. Once they're in a much tighter formation, there's 6 points of contact, which means that that soil particle, that soil structure is much stronger. There are more points of contact between the soil particles. These next two are for hastening the consolidation. Sometimes it can take 6 months to a year to 2 years for the soil to fully settle after a load's been put on it. Obviously that is undesirable. You can't wait 1 to 2 years. For most civil engineering projects, they want to hasten the settlement, and the problem comes because you're putting a load on the ground with the compaction and stuff like that, but for the actual sediment to happen, the water in the soil voids needs to be ejected from the soil matrix, and that can happen very slowly in things like clays and silts. So what a wick drain does, and these are pictures of wick drains, is it shortens the path that a soil particle has to travel to get out of the soil matrix. So here a water particle down the bottom there has to travel all the way up to the surface at a very slow rate before it's out of the soil matrix, and until all the water particles are out to equalize the pore pressures with the overlying load pressures, the soil is going to keep on settling. By putting in wick drains, you're putting in a a permeable column, either sand or geofabric, which means that the path for the water particles to get out of the soil matrix is much shorter. They only have to go horizontally a certain distance, and then they hit the permeable layer and they come out of the soil matrix much faster. So once it hits the permeable layer, it's like hitting a motorway. Off you go, much quicker. It's often used in conjunction with preloading. Preloading means that you put load extra over top of what the actual loading of the structure or the road's going to be. That means that there's more pressure there, pushing those water particles out of the soil matrix, which hastens the process as well. So using preloading and vertical and wick drains together means that it's happening much quicker. But you can use both methods individually and separately. Stabilisation is a way of making the soil stronger by tying together those soil particles much better than what they had before. There's two ways of doing it: lime stabilisation and cement stabilisation. Lime stabilisation is especially effective on most clay soils, but you need to do lab tests to make sure that the soil is actually compatible with lime. Some soils aren't, so you need to do soil tests to make sure. So it's addition of hydrated lime. When the lime is wet up, it becomes quick, and it will collect the finer particles into larger particles. It's like a low-grade cement. It also dries the soil and makes a more stable soil matrix. It means that the expansive properties of the soil are also reduced. So when it gets wet and dry, it's not going to swell as much as it would have otherwise. Cement stabilisation can also be used, and the method is much the same. So the advantages are it increases the strength, reduces the plasticity index, which means it's less sensitive to water. It's less likely to go into that liquid state where it gets very soft and can settle. Provides a moisture barrier, increases the stability. So the stabilisation process involves, usually it works in a train like this. So you've got the truck laying down hydrated lime. The lime, they don't show it here, but oftentimes you'll have a water truck wetting it up. Once the lime is wetted up, it becomes quick, and there's a certain period of time that you can mix the soil in with it, and then it will dry with the soil to form a very, very hard material. So you wet it up, you put the hydrated lime on, you rotary hoe it into the ground, so you're mixing up the soil and the hydrated lime together. You then shape it, compact it and shape it. You need to do that because a few hours or a few days later that material is going to be too hard to compact or shape. So normally you do it all in one operation. Lay down the lime, mix it in together, compact it, shape it, then it's all ready to go. So there's a truck laying down the lime. You can see that lime is actually quite a toxic material, so you need to take precautions with that, with breathing and also trucks. You can see the rotary hoe here. The next picture is going to show this in a little bit more detail. So the truck's come along, it's laid the lime, you got the rotary hoe sort of mixing it all up, and then following in behind is the compactor compacting it down, and then there'll be a grader in behind that as well. So here's a picture of the rotary hoe. The lime has been laid on the ground. There's the soil. It comes along and there's this great big spinning wheel sort of digging up the lime and the soil together. It all gets mixed up together, and then it's all mixed after the rotary hoe's been through. So that allows the lime to be totally mixed in with the top 200-300 mils of the soil, and then that will harden to form a very strong layer.